So when we last left off from the previous lesson, we were saying to ourselves, gosh, wouldn't it be great if Box2D provided us with a way of applying a force to an object rather than having to set its velocity directly? And as it turns out, Box2D has not one, but two exciting ways of doing that. And let's take a look at those right now. So Box2D has two functions that are both part of the B2 body class that allow you to apply a force to an object. There's something that is called, appropriately enough, apply force, and there's something else called apply impulse. They both do essentially the same thing, but they do it in kind of different ways. Apply force is generally a function that is used to apply force over time. It's intended to be used over the course of several frames as you gradually want to apply a force to something and then eventually turn it off. So examples might be if you were to make a character in a game that had a jetpack, or if you wanted to simulate the wind. Both of those would probably make use of apply force. Apply impulse is used to apply a force all at once. It's generally intended to be called once and then forgotten about. So examples might be if you wanted to create an explosion that knocked things over, or if you had a character in a game that you wanted to jump, you would just apply the impulse once to make it move straight up. Or say if you wanted to simulate a peg getting hit by a ball in a Peggle type of game. Oh, hey, wait, that's what we need. So figuring out how to use apply impulse, if you look at it, it basically asks for two arguments, force and point. So the force is essentially the force that is being applied to this object. And force here is being defined in newtons, which I believe is kilograms times meters over seconds, or maybe seconds squared. In any case, there are two important things about this vector that Box2D uses. One is the direction of the force, and the other is actually the length of the vector. So size matters. If you were to apply a B2 vec2 that was of length 1, it would be a much smaller force than if you applied something that was of length 30. And then the second argument is the point, and that is where on the body the force is being applied. And this matters if you want some realistic rotation to be applied to the object that you are applying the impulse to. So, for instance, if I have a rectangle here and I want to apply a force directly to the center of it, that will basically just move my rectangle to the right. On the other hand, if I have a rectangle and I apply a force at the bottom there, my rectangle is going to kind of move to the right, but it's also going to spin pretty hard. And so where you apply the point in relation to the center of mass of this object is important for determining whether this object rotates or not. So now that you kind of understand how apply impulse works, let's go back to our application and maybe apply a force in a more realistic way. So looking at our peg actor here, I think here's what I'm going to do. I am going to replace my ball velocity vector with another vector that I'm going to call ball force. And I suppose really, just to name it better, I'll call it ball force to apply, so that I know that this is a force I'm going to eventually be applying to this peg. Now when I go down to my set collision info, I'm going to pass in the velocity of the ball, but then also important for calculating the force that will eventually be applied is the mass of the ball. So I'm going to pass in ball mass as well, and this is a number. Basically, ball mass will be in kilograms, ball velocity is still in meters a second, and so to calculate my ball force, I'm basically going to take our ball velocity, still going to copy it. Remember, you'll probably have all sorts of weird and interesting side effects if you don't. And then I'm going to multiply this vector by the mass. And then I no longer need this. What you're going to end up noticing, by the way, is that this force to apply ends up looking like a fairly small number. In our case, I think our ball is something like 80 grams, and so the ball mass is going to be fairly small, and so it's going to look like our force to apply is small, but this ends up being a pretty significant force when you use apply impulse. So continuing that thought, let's go down to our turn normal function, and instead of directly setting the linear velocity, we're going to apply impulse. The force is going to be the ball force to apply, And then the point at where this happens, I suppose technically should be the point at which our ball has collided with this peg. However, given that our peg is a perfect circle, and given they don't really care too much whether it has the completely accurate amount of spin applied to it, I'm going to simplify matters a little bit and just apply this impulse to the center of mass of my peg. It turns out I can do that very easily by taking a look at the body and calling this function get world center. What this function returns is the center of mass of my body defined in world coordinates. Don't be fooled by the name, which might make you think that it's actually getting the center of your world. It's not. It's getting the center of your mass. And so this will actually work pretty well. All I need to do is go back to my contact listener and make sure I am passing in the velocity and the mass of the ball to my peg actors. So let's go back to our set collision info function. I'm going to kind of neaten up my formatting a little bit. And so I still have the velocity, and I'm going to get my shapes body. And then there's Box2D has a function called getMass. And this function, like you might expect, calculates the mass of my object. I can do the same thing down here, just doing it with shape 1. And when I run all of this, so let's see what we get here. Well, all right, I think this is looking a little better. The balls seem to be, the pegs seem to be reacting a little more realistically than before when my ball runs into it. So I would say this is a bit of an improvement. Now it turns out there is still one more issue that maybe we need to address. And that's the fact that if you look at, say, this peg here, if I were to just graze it on the right side here, you'll see that that red peg went straight down instead of what you might expect it to do, which is kind of shoot off to the left. Again, we're kind of getting into like super nitpicky mode here, but I suppose if you want to bear with me and refine this a little bit further, we can look at fixing that weird little situation in the next lesson. So stay tuned for that, and then we'll move on to other things, I promise.